Hello everyone. A while back in one of my mail goodies episodes, I received some logic gates and my plan is to build a binary adder with them. For today's episode, I wanted to take a look at some basic logic gates, the NOT gate, the AND gate, and the OR gate. With these three gates, you can construct any other logic gate you want. So I'm going to build these gates by using some discrete transistors and some regular quarter-watt resistors, as well as a couple LEDs. Before we build them, I have the diagram and symbols here for each of the gates. So first here we have the NOT gate, which is also known as an inverter. A NOT gate symbol is a sideways triangle. On its right point there is a small circle. This small circle is called a bubble. When applied to a logic gate, the bubble means that the gate is inverted. So the NOT gate here is the simplest of the transistor logic gates we're going to build. It only requires one transistor and two resistors. The input A goes through a high value resistor into the base of the transistor. VCC comes into the transistor through its collector. The emitter of the transistor is connected directly to ground, and the output is attached here between the VCC resistor and the collector of the transistor. The resistor on the base is to prevent any leakage going from the base to the emitter or back up through the collector. So it's just to protect the base of the transistor there. So the truth table here for the NOT gate is very simple. If the input is 0, the output is going to be 1. If the input is 1, the output is going to be 0. Okay, so I have a breadboard here that's prepared to make the gates here. We're going to do the NOT gate. So for the NOT gate we have one button. This is going to be the input. We have a couple buttons here for the AND gate and a couple buttons here for the OR gate. I've tied the negative and positive rails together on the sides here, and I have my battery connected over here. Okay, so we have this set up now. We'll turn on the power. You can see the LED lights. That's because right now the input is a 0. If we put an input of a 1, the LED turns off. So the inverter circuit is working exactly as intended. The VCC is connected to the button here, which is acting as the input. It's going to the base of the transistor here with this 10K resistor. The collector of the transistor here has a 5.2K resistor connected to it, which goes from VCC to the collector. The emitter is directly connected to the ground, and the LED is acting as the output, so the LED is connected between the collector and the ground. So normally current's able to flow through the LED here to ground, but when we apply a current to the transistor, it turns on and allows the current to sink through to ground without going through the LED. That's the inverter circuit. So next we have the AND gate. So the symbol for the AND gate is this kind of bullet shape here. The AND gate has two input pins and one output pin. So I've marked those as A and B are the inputs and C is the output. A lot of the time what you'll see is that AND will be actually written inside the symbol here. Now if AND is not written inside the symbol, it's very important to check the output and make sure there's no bubble on it. If there is a bubble on the output, you're dealing with a NAND gate, not an AND gate. A NAND gate is just an AND gate that has a NOT gate on the output. For the AND gate here, we're going to need two transistors, one for each input. We're also going to have the two inputs coming into the bases of the transistors through a high value resistor, just like on the NOT gate. VCC is connected to the collector of the Q1 transistor. Then the Q1 transistor's emitter is connected to the collector of Q2. The emitter of Q2 is connected to ground through a lower value resistor, and at the point where the emitter connects to the resistor, we have our output, which is C. The truth table is more complex for the AND gate, so if input A is a 0 and input B is a 0, then it's going to output a 0. If either input A or input B is a 0 and the opposite is a 1, then it's still going to output a 0. But if both A and B are 1s, then it's going to output a 1. Here's the AND gate. So you can see the LED is off. If we press A, nothing happens. If we press B, nothing happens. But if we press A and B together, the LED turns on. The two switches here are connected to the VCC. They come out through the 10K resistors to the bases of the transistors. Transistor A here is connected through to VCC on its collector. The emitter of it is connected to transistor B. The emitter of the transistor B is connected through a 5.2K to ground, as well as through an LED to ground. So the LED is acting as the output of this circuit, just like on the NOT gate. And finally, for this episode, we have the OR gate. So the symbol for the OR gate is very similar to the AND gate, except it has a concave side here on the left. I also marked it with A, B, and C. So for the OR gate, there's going to be the two inputs coming in, again through high value resistors into the base of the transistors. VCC is going to be connected directly to the collector of Q1 and Q2. The emitters of Q1 and Q2 are both going to be connected together. And this is the point where we'll actually grab the output, which is C. And then those are going to be connected to ground through a lower value resistor. The truth table on here is very simple. If A and B are zeros, then output will be 0. But if A or B is a 1, it's going to output a 1, and if A and B are 1s, then it's going to output a 1 as well. So the only time an OR gate will output a 0 is if both of the inputs are zeros. Finally here, let's do the OR gate. There's the completed OR gate. So for the OR gate, anytime A or B is a 1, or if both are 1, it should turn on. So right now we have a 0 and a 0. So now we have a 1 on B, and it's on, a 1 on A, and it turns on, and if both of them are 1s, then it stays on as well. So here we have the VCC coming into the switches, just like the other ones, going out through a 10K resistor to the bases of the transistors. The collectors of these transistors are both connected directly to VCC. The emitters are tied together here, and the tied together emitters go to ground via a 5.2K resistor. There's also a LED which is acting as the output from that connection. It's going through a little 330 ohm resistor just to make it a little less bright, and it's going to ground as well. So those are the 3 most basic of the logic gates. In the next video we'll be looking at the Nand Gate, the NOR gate, and the XOR gate. So I hope you enjoyed this episode of Tinkering with Terrius. If you did enjoy this episode, then please give it a like. If you didn't enjoy it, then give it a dislike. If you want to share this episode, feel free. If you have any questions or comments, please leave them in the section below. Otherwise, you can email them to me or tweet them to me. If you enjoy my channel, please consider subscribing to it. Every subscriber helps. Thank you for watching. I hope you have a wonderful day.